I made another awesome app that I want to show you. This one is a dashboard that uses GPT for creating language model training data from text that you can then save to a Tigris storage bucket. Thank you to the team at Tigris for sponsoring this video. It has been a great experience working with their team and their service. If you haven't seen my other video deploying an object storage CRUD app using Tigris storage on Fly, get down in the description for that link. Let's get into this app so I can explain what it does. The home page is where the majority of the magic happens. Here, users can select what format they want the created training data to be in. The specific format needed depends on the model being trained or fine-tuned. After selecting the desired format, users then type in or paste in the text to use for creating the training data and then hit submit. The text is sent to GPT using the Openai API with instructions to convert it into training data. I will show you how to set that up a little bit later. The response comes back here after it is done loading. If the created training data looks good, users can click the Save button and the data is then saved in a Tigris storage bucket. In the examples page, there is an example for each format. Users can select a format and see what a prompt and successful response would look like for each format. The last page is a list of all the currently saved training data that a user has. They can also select them and delete any that are no longer wanted. If you want to see how I built this, stick around. We are doing that right now. I built this using SvelteKit for the framework. I am deploying this on Fly.io paired with Tigris for object storage. The formats are all JSON objects in different structures, so object storage is perfect for that. For the GPT, I am using Openai. I covered the setup for Fly and Tigris in my other videos, so refer to them if you need the details, but a quick overview is that you create a Fly account on Fly.io. Tigris has a form you fill out to link your Fly account to Tigris for object storage. The command line tool from Fly called flyctl has the Fly storage command that will create everything you need to use the object storage, including a bucket. From Openai, you will need an API key. To get an API key for using their API, you go to your Openai dashboard and in the section appropriately labeled API keys, you create a new key. In the project source, you will need to put all your environment variables into your .env file, of course. And you will also need to add the AWS S3 client, the adapter node, and the Openai packages to your project as well. In your svelte config.js, then swap out your adapter auto for adapter node. Alright, that is the setup. Now let's get to the fun stuff and jump into our project source. As always, if you want the source code for this, I have it available in my GitHub, linked down below. In our homepage, let's take a brief look at the markup. Most of this is just a straightforward form and some auxiliary code for handling the response after submitting the form. One thing I wanted to point out is how I handled the pasting text. For that, I am using browser from Svelte to make sure that we have moved off the server from server-side rendering. When we're sure we're in the browser environment, I attach a window listener. This checks that the clipboard API is available and also that the event is a paste event. Lastly, that the pasted data is a string, although you could expand this to accept files if you wanted to. If everything checks out, then when someone pastes text, it will parse it out and save it to the form. I am also counting tokens here for the user so they know approximately how many tokens they have left to use. The model I am using starts at just over 16,000, but I use some myself before the user has a chance. If they are over the limit, they can't submit the form since it would get rejected by Openai anyways. So let's go look at the back-end logic for this page. All the secrets with AWS in the name are for interacting with our Tigris object storage bucket. We then have the API key for Openai. The other imports are kind of self-explanatory. There is no load function for this page. We just have two page actions. The first, complete, is where we interact with Openai to complete the chat to generate our training data. And the second, save training, is where we save our training sets to our Tigris bucket. Let's go through these one at a time. In our complete action, we get our form data, which has our prompt, any pasted text, and which format the user has chosen. Next, I have a couple of constants. The first one is all of the possible formats, and the next one contains a list of examples for every format. And I'll show you what we're going to do with those in just a second. Then I pull out the group to find out what format we're going to use. Here are a couple of trainings, and these are going to be critical to making this work. We have a standard response object that I fill in after I get a response. Here we take a undefined assistant variable, and then depending on what format, we pop in the appropriate assistant text from out of our examples object up here. After that, we fire up a new Openai client. I am using GPT 3.5 Turbo 0125 because of its lengthy context window. As I said, we have just over 16,000 tokens to use, and you'll notice here that this format, messages, an array, role system, role user, role assistant, might look familiar. This is because in order to train the 3.5 models, all of them go in this format. There is an object with one property called messages, and then inside of the messages array, you can have 3 different types of messages. You can have one for the system, and this is where we tell it the training. Here the training is telling it to take whatever is coming in and convert it into training data and some formatting stuff. And then this is also where I punch in what format to use for it. The next is the actual prompt. This would be, in our case, either what was typed or pasted or both. And then the last is called assistant. This is some helper text that 3.5 uses in order to better understand what you're wanting it to accomplish. So here we're pasting in whatever example makes sense for which format they chose. After we have all of that stuff plugged in, we simply fire off our prompt to GPT, and then we pull out the response and send that back to the front end. So one thing that I'll point out here is that this is kind of a shortcut because you can get pretty good results with just using this setup one time. To fine-tune a model, you have to pay additional fees to fine-tune it, and then it costs you a little bit more to use it after it's fine-tuned. This doesn't actually count as a fine-tuning. We just have the ability to send up to 5 messages when you're using 3.5 in a standard API call. And so that's what I'm doing here. I'm just short-circuiting those extra fees, and I'm just using some of those messages to do a minor training, a minor fine-tuning before we send it the actual message. The next action that we have is our save training action. This one is pretty straightforward. This one, we take our trainings, which might be more. We are also telling GPT that if it thinks that it should be split to multiple trainings, to go ahead and do so, to just make sure to add a new line in between each training object. That way we can come in here and grab them one at a time. If there's only one, we just fire up our client, we stringify the training, and send it to the bucket with an ID. If there's multiple, then we just iterate through them one at a time, using the put object command to put each object one at a time in our bucket. So that's the bulk of the magical logic behind how this works. We can take a little peek at our examples page. This is a simple page. There isn't even a backend file for this page. The formats and examples are in here as constants. There's a reactive statement for updating which is selected. I added the formatting into the constant and used a pre-element to accomplish the formatting. That is all there is for that page. Let's move over to our saved training data page. The markup for this is also fairly simple. We are just iterating through the saved training objects, and depending on what kind of training object it is, we render an HTML chunk I put together specifically for that training object. You could just stringify each of the training objects inside of a p tag, but they have better formatting this way. Besides that, this is a form that we will send to our backend a list of IDs to delete if a user wants to delete any. In our backend file, we do have a load function for this page. In our load function, we just fire up an object storage client, get a list of objects from the Tigris storage bucket, then go through the list obtaining each object which comes through as a stream. We convert the stream into a string, which we then parse back into JSON and add into each object the key. That way we have them in the front end to be able to track which ones a user selects to delete. Then we send this list to the front. Lastly, we have our delete form action. This takes the list of IDs from our front-end form, and then we iterate through the IDs and delete each object one at a time. Pretty straightforward. So there is the language model training data creator. I hope that you enjoyed this video and found it helpful. I had a ton of fun putting this together. Comment below if you are working on any fun projects using large language models and what models it is you are using. Take care, and as always, have a great day.